Welcome, and thank you for attending this webinar, where we'll talk about shifting your application and CI/CD pipeline to the cloud using Cloud Hybrid. I'm Leanne Crocker, a continuous delivery architect here at Octopus Deploy, and I'm joined by Sean Cessna, also a CDA. How are you doing, Sean?
I'm doing pretty good. It's a bit chilly this morning, so I got my Octopus hoodie on, so I'm doing all right.
Well, it's lovely and sunny in southern England, surprisingly. So, okay. Today, we're going to talk about what is a cloud environment, first of all, just so that we're all on the same page. Then Sean's going to take a look at any challenges you might come across with Cloud Hybrid. And then he's going to look at continuous integration in a Cloud Hybrid environment, and then give us a demo using GitHub Actions and a self-hosted runner. After that, I'll take a look at continuous deployment in a Cloud Hybrid environment and deploying Cloud Hybrid and things to consider when doing that. And then I'll take a demo, do a demo of looking at using Octopus to move to using platform as a service infrastructure. After that, as I said a moment ago, we'll try and answer any questions that have popped up. Okay, so what is a cloud environment? Cloud hybrid environment? Well, a hybrid cloud is where there's a mix of infrastructure, some of which is in the cloud. Hybrid cloud deployments can combine public and private clouds, and they may also include on-premise infrastructure. So a private cloud infrastructure, that's infrastructure that's used exclusively by one company. It could be virtualization hosted on-premise on an internal network, or it could be it's on dedicated infrastructure that's managed by a cloud service provider, and an off-premise data center. It's also sometimes known by the names corporate cloud and internal cloud. As it's used exclusively by one company, it can be tailored to that company's requirements, and it's generally seen as being more secure. However, private clouds are more costly, and depending on the hardware setup, mean you could introduce some sort of scaling limitations with sort of hardware availability and things. Public cloud infrastructure is available for use by many companies, and it's over the public internet. So you've got examples like Amazon Web Services, Google Cloud, and Microsoft Azure. Public clouds are generally less costly and are incredibly flexible. They allow to have, rapid spin up, tear down, scaling out and up. And because public cloud infrastructure is not exclusively owned by one company, it's sometimes again seen as potentially less secure than that private cloud. And you do find that sort of certainly with those bigger names like Azure and AWS, you do find that they're widely targeted by attackers. So you do have to be extra careful that you've got everything locked down and configured absolutely correctly. Okay, Sean, over to you.
All right, challenges with Cloud Hybrid. Challenges in the Cloud Hybrid environment that you're probably going to run into are connectivity, security, latency, and transition. When talking about connectivity, that could be something as simple as just opening up a few ports so that your on-premise can connect to your cloud resources. Or it could be full-on integration between the cloud network and your network, such as a site-to-site VPN connection. Regarding security, that's probably going to fall down to a lot of firewall rules between the cloud resource and your on-premise resources. And it's going to be really important that you get those firewall rules correct so that you can limit your attack surface. As Leanne talked about previously, you can get attacked on public cloud environments quite often. Next, we have latency. Latency can be both a pro and a con. If you're moving what used to be an on-premise resource to a cloud resource, the resource may now be hundreds of miles away in some data center where it used to be located in the next building or in the basement. So there may be increased latency to access that resource. Conversely, it may be a good thing in that you can locate your application in a region to where your customers have less latency. In terms of transition, you may need to decide what resources you want to move to a cloud hybrid first. That might be web code, that might be database code, or it could even be a build server, which is a nice segue into the next slide of CI in a cloud hybrid environment. Continuous integration can come in a couple of different flavors. The first being you have an on-premise build server that produces artifacts that are later deployed to cloud environments. Or you could have a cloud build server, such as Azure DevOps, GitHub Actions, or Bitbucket pipelines, where the source code is hosted in the cloud and perhaps even builds. Some of these cloud build servers allow to have local build agents, and there are some distinct advantages to having a local build agent. The first being that you're able to control the version of software used to build your software, such as like .NET versions, Java, stuff like that. They also don't charge build minutes if you're using a local build agent, or compute time, whereas some of the cloud hosting providers for build servers will do that. And lastly, the local agent will be obviously local to your environment and have access to local resources. If you're using a pure cloud build server, such as Bitbucket pipelines or Circle CI, those will build only on the cloud. And if you need to push packages to your local environment, your only recourse is to open up your firewall to allow that to happen. Most of these cloud service providers are going to give you a static IP or a IP range to allow for that. And also the build agents might be shared as well. If none of those solutions work for you, you could go with a third-party hosting solution for your feed, such as Artifactory or Nexus. This will give both your on-premise and cloud resources a central point that they both can access. Okay, I'm going to give a demonstration of how to add a self-hosted build runner to GitHub Actions. For those who are not familiar with GitHub Actions, that's GitHub's build server. What I'm going to do is I'm going to hook up a local runner that's going to listen for an event. When the event occurs, it's going to pull the source code. It's going to run the build locally and then push those artifacts to my local instance. Let's see what this looks like in action. So for this demonstration, I'm going to be using the Octopus Shop application in our Octopus samples repo. GitHub Actions build definitions are what they call workflows. But before we can do a workflow, we need to set up the local runner. So to do that, you click into Settings, and then go over to Actions. And then they've got this Add Runner button. This brings us to a form that asks us to describe what our local runner is, such as operating system and architecture. As you can see, it supports Mac OS, Linux, and Windows, and these instructions that you see on the screen will change based on what your selections are. Under the architecture one, we have x64 and ARM, so in theory, you could actually have a Raspberry Pi as your build runner. I've already created a VM to be our hosted runner, and I've pre-installed some software on it so that make the build go a little smoother. So I've already installed .NET Core and then the Octopus Deploy CLI. I've also taken all of the instructions you see here on the screen and put them into a script file so that I can have it go quicker. So as you can see, I've already SSH'd into my build runner. I've put all of the instructions into a script file called GitHub Actions runner. So let's go ahead and run that. Right now, it's downloading the runner. So depending on your connection speed, it takes just a few seconds. It's going to authenticate against GitHub. All right. It's going to ask you a couple of questions. The first being what I want to name it. Just going to take the default. By default, it's going to apply the labels of self-hosted, Linux, and x64, and it's going to ask me if I want any more. I don't, so I'm just going to hit enter. And lastly, it's going to ask me where I want to put the work folder. All right, our runner has been connected to GitHub and is now listening for jobs. If we click back on Actions here, we can now see that my local runner is connected and ready for work. All right, so let's go back to the code. I'm going to switch over to my demo branch here so I don't muddle up with commit messages. As I told you before, this works on what they call workflows. Let's pop into a workflow here. Unfortunately, GitHub Actions doesn't have the ability to manually kick off a build. All builds are done based off of events. So let's take a look at my build definition here. In this one, I've told it that I want it to kick off anytime there's a push to the demo branch or a pull request. So let's just simulate a push here real quick to get that build going. We'll just put a space in here just to have something different, and we'll commit that change. One thing before I forget, in order to tell GitHub Actions to run on the self-hosted runner, you need to come in and then change this runs on section here. As you recall, it gave the runner the labels of self-hosted, Linux, and x64. I've told this workflow to execute on anything that has self-hosted and Linux. So let's bring up our, we can see that our runner has already picked up the job and is executing. So let's take a look at Actions here, and let's take a look to see what's going on. We can see that our build is underway already. Click on build here, and it's just about done. Awesome, that was actually pretty quick. So I'm going to open up this push database step here. And we can see, based on this output, that it pushed version 2020-6.17.33 to my local instance of Octopus deploy. So here we are on my local instance. This is not internet accessible. It's on my local infrastructure. So I'm going to click over into library here and filter on Octo Pet Shop. And we can see that it did indeed push that version to my local infrastructure. So this was a demonstration of how to use a cloud build server with a local runner to simulate a cloud hybrid environment. All right, over to you, Leanne.
Thanks, Sean. That was really awesome. Thanks very much. So have you found many customers have been asking for this sort of thing and they're using this sort of out, every day?
I did. I had one customer contact us. They were moving all of their infrastructure from on-premise to the cloud. They had already moved their Azure DevOps and were wanting to still push packages to their local environment. They wanted to know how they could do that. And I said, the best way you can do that is to use a local runner.
Yeah. Yeah, it's a great way of getting around those little network issues. Awesome. Okay, so moving on from continuous integration, let's take a look at continuous deployment. So Octopus can obviously be used for your continuous deployment, and it's really excellent of the different ways that it can be used in a cloud hybrid environment. There's a couple of options when it comes to Octopus. We have Octopus Server and Octopus Cloud. Octopus Server allows you to install Octopus on your own infrastructure or on a virtual machine in the cloud. Installs a Windows service, which gives you access to the web portal and the API, and it sets up a SQL database for the backend. Octopus Cloud is our platform as a service version of Octopus. You can go to our website and sign up to the cloud product, and within a very short amount of time, be deploying code. An added bonus here is obviously that because it's a software as a service, not platform as a service, that we do all the maintenance for you. So you just log onto the website and use the deployments. In the future, you can see here we've got Docker on the list. We're going to have the option of running Octopus Server in a container. A Windows container is already available, and the Linux container is part of our early access program at the moment. Octopus Server can be configured for high availability, so there are some special considerations to take into account when you're setting up a self-hosted instance of Octopus Deploy on cloud virtual machines with high availability. For example, in Azure, the Azure file storage is able to be shared amongst multiple virtual machines. However, AWS Elastic File System can only be mounted to a single EC2 instance. So it's worth sort of considering where you're going to host it, what cloud technologies you're going to use, and sort of how that might affect things like this. Octopus Cloud doesn't have the option of high availability configuration, but all instances are provisioned as a Linux container. We run them on Azure's Kubernetes service. So that's their managed Kubernetes. And this helps us achieve the resilience and scaling flexibility that we need. Let's take a look at a few of the differences you get here with and considerations. So one difference that there's some slight differences on authentication between Octopus Server and Octopus Cloud. So with Octopus Cloud, you use your Octopus ID to log in. So this is either a username and password, or it can be linked to your Google or Microsoft account. Octopus Server, like Cloud, it can use Microsoft and Google authentication, and it can also be configured to use Active Directory or plain username and password. If you do configure Active Directory, you can even map those external groups and roles to Octopus Teams. So you could use, maybe Azure Active Directory if it's in the cloud, and you can actually mirror an on-premise Active Directory up to Azure Active Directory as well. Within Octopus Server, you can also configure multiple authentication providers. So should you be going through maybe a transition period, you can sort of overlap those, or just ongoing use multiple. Moving on to listening or polling tentacles. So these, you always have the options, whichever Octopus instance you're using, of listening and polling tentacles. So these are your workers or your deployment targets. And Octopus Deploy has the unique ability to deploy to both on-premise and cloud targets. And it really opens up some possible configurations which may previously have been limited because of firewall restrictions and things like that. And we'll include some links in the emails that will give you some further readings on how that can work. And finally, region. So when you're looking at using cloud infrastructure, one consideration is region. So for example, if you're using a cloud virtual machine, you might want to host that in the closest geographic region. So you obviously get the choice wherever you want to go, if it's your own virtual machine. With Octopus Cloud, as I said previously, we host in Azure, and we currently offer you the choice of West US, West Europe, and Australia East as your regions when you're setting up your Octopus Cloud. So it's worth considering that. Okay, so that's Octopus Deploy itself. Now let's take a look at when you're actually deploying your application to cloud hybrid infrastructure. So the first thing you're going to think about is that infrastructure itself. So within Octopus, we've got runbooks, and we've found these are a fantastic way to spin up infrastructure as code. And this just gives you so much flexibility. So let's imagine you've got a team of testers. And one of those testers needs to go off and work in parallel with the main team to test a hotfix. What you could do, you could use a runbook to spin up a temporary environment in your whatever cloud infrastructure that you've chosen. And that can exist for the time it takes to test that hotfix and then to push it into your staging and production environments, let's say. And then you can tear it down again. Let's just show you a quick example here. in our samples instance, we've got a runbook here. What this does is it spins up an environment for our pet clinic application with Google Cloud. It goes through and it creates the database, and it actually sets up the Octopus deployment targets as well, and goes through, configures a load balancer, and notifies everybody on Slack when that's completed. So it's just incredibly useful. And then you can go in and you've also got, things to destroy and, tear down that infrastructure afterwards. Once you've got your infrastructure, obviously you don't have to do it that way, but it's a really flexible way of doing it. And this means you can then use maybe a mix of on-premise and cloud hosting. So it might be that your staging and production environments, they're all potentially on on-premise hosting, and all your development and testing environments are a bit more flexible and change regularly, and you have them on different infrastructure. You've got the flexibility to do that. And when you're setting up your Octopus deployments, you can actually scope parts of each of those deployments to different environments. Let me just show you what I mean by that. Here we've got this same application that Sean was talking about previously, Octo Pet Shop, one of our favorites here. And this is a sample he's created where it goes in and it's deploying the SQL database, going through, and it's deploying the website and the two APIs here to IIS. So that's these 3 steps. And all these 3 steps, all they're doing is deploying to development and test environments. If we go down and look at 7, 8, and 9, these are also deploying the website and the 2 APIs, but they're deploying to staging and production. And rather than deploying to IIS, they're actually deploying to an Azure web app. So by scoping the steps to the environments, you can choose that maybe they would go to different infrastructure. Another way to scope it is if you're deploying to different tenants. If you've got tenants set up, maybe you're deploying your application to multiple customers. And it might be that you want to transition those customers one by one onto some separate infrastructure, some new infrastructure. So you can use tenant tags in order to determine which infrastructure their software gets deployed to. Or it might be that it's not necessarily a transition period. It might be that some of your tenants, some of your customers have actually paid for dedicated infrastructure, whereas some use shared infrastructure. Again, this is where tenant tags really come in use. So I'm going to actually show you how we use tenant tags here, and I'm going to adjust this project to start using from entirely on-premise infrastructure to start using some platform as a service. So here we've got random quotes. This is an application that does as it says, it creates random quotes. At the moment, our hosting is entirely on-premise, and we've got this for both of these 2 here. So what I'm going to do is take a look at their tag set. So we've got a tenant tag set up here, and we've got hosting of on-prem and also platform as a service. So if I take a look at our tenants here, you can see avid readers I've got with platform as a service. They've selected to be one of our tenants that goes to platform as a service, and this one is going to stay on premise. The platform as a service infrastructure we're going to use here is I'm going to move from on-premise SQL Server to SQL Azure, and I've already set up my Azure SQL Server. I'm going to create some databases on here to be used. So this is the process that's being used to deploy currently to our on-premise infrastructure, setting up the SQL database, running some scripts, and finally deploying to IIS. So there's a few things I need to change here, but not a huge number. So the first thing I'm going to do is I'm going to set a few variables. Okay, so the first thing I'm going to do is create a variable for our Azure account. So this is the account that's going to enable us to access the subscription on Azure to set up this infrastructure. So I need to change that to an Azure account. And next I need to add another variable so that we know which resource group we are going to be deploying to within Azure. And now down here, we've already got our settings for the database. We've got the IP address, which is the SQL server that's going to be used. So this is our on-premise variable that holds the details of that server in one of our global variable sets. What I'm going to do is going to add a value. And in there, I'm going to put our Azure SQL server, and then I'm going to scope these to those tenant tags that we've defined and put against those tenants. So this one is our on-premise one. So let's assign that. I'm going to do this for the platform as a service. Okay, and I'm going to do the same here for the user for that SQL server. Again, I'm going to scope them to these tenant tags. Oops. Then we've got the password. Okay, and finally, just one more, just so that we can prove that we are adding our value in. We are going to set our app settings, which will show in the footer a value of where they're hosting. So we're going to add a value on here. I'm going to put platform as a service. Okay. So that's all of our variables done. Let's save those. And now we're going to just change one of these steps here. So this first step here is running a SQL script to create the database if it doesn't exist. Now, I know for a fact that this will not work on Azure SQL. It will only work on SQL Server itself. So I'm going to scroll down to the bottom here, and I'm going to scope this to only run on our on-premise tenants. And then I'm going to add a script in. So I'm going to use one of our inbuilt Azure scripts steps to run an Azure script to create database if not exists. I'm going to move down and I'm going to get it to use the account that I configured in the variables a moment ago. So here we go. And I'm going to supply it with a script that I have here. Now, ideally in the real world, you would generally use an ARM template, but this is just a quick way to get a database up and running. So this is using the Azure CLI. And first of all, it's checking if that database already exists. And if it does not, it's going to create that database. Okay. And finally, we're going to scope this. So again, it's only those platform as a service tenants. Right, so let's just move that step up to the top because we don't want it running last. Okay, fantastic. Right, so let's just create a release. Save that, and we'll deploy that through to our dev environment for both of our tenants. So as you can see here, you don't have to do both of them, or I could have selected it by hosting tags. Right, let's push that through. So while that's running, let's take a look at what it's doing. So you can see here, this is running on Avid Readers, and Avid Readers was the one that's going to our platform as a service. So what you can see is it's skipped over step 1 and it's going directly to step 2 to Azure Create Database. And conversely, the bookworm is jumping over step 2 and going 1 and 3. Okay, so what you can see here is, now I have noticed a bug here in the application, but even though we're going to the Avid Readers apps, I can see that the footer is actually wrong. So ignore that part, but do look at this part here where currently when we're on version 13, you can see it's on-prem. And it's currently deploying 14. And we'll just wait for it to finish that IIS step. And then we'll refresh the page and it will show us that it's using SQL database. Now, probably in the real world, you would use your website in the cloud first rather than your database, just purely due to latency issues which could arise. Obviously, depends on the connection you have and the network you've got set up. But this is purely to show you how you can scope these roles to those tenant tags, those steps. All right, so this has actually finished that deploy step and it's just applying the retention policies. So I will now go ahead and refresh that page. And what we'll see is this is version 14. Oh, and we have updated the footers now, which is lovely. And it's also on platform as a service. Okay, so that's that. Right. Okay, then let's have a look and see if we've got any questions. Oh, we do. Yeah. Right. So first question we've got here is Sean. This is quite an interesting one. Do you have a favorite cloud provider and is there a particular reason for that?
I have one I am partial to. Azure has done a really great job in making their ARM templates really, really easy to generate. So I tend to gravitate towards Microsoft Azure purely because it's much quicker to get something up and running, in my opinion. CloudFormation is great, but I find it especially when you're a new user, that it can be quite overwhelming to try to get running.
Yeah, I do agree with you there. Although I do find CloudFormation templates are really good for getting virtual, when you actually get them, the virtual machines do tend to spin up really quickly, which is pretty cool. Next question is, are there any plans to provide native account support for Google Cloud? Yes, there are. We do have plans in the pipeline to get a Google Cloud accounts, and also there'll be some specific step templates built in for Google Cloud deployments. Next up, Sean, there's one here. How do I set up high availability with Octopus Cloud Platform as a Service?
Unfortunately, the high availability option isn't available for the cloud platform, but we do make use, all of these are inside of Kubernetes clusters. So Kubernetes has the ability to scale up and scale down and then also automatically recover should something crash. So you still get high availability, just not in the traditional Octopus sense.
Excellent. Yes, totally agree. And there's one more. Where do you start planning for a migration from on-premise to the cloud? Well, I would imagine this is a question talking about maybe what parts of your application would you move first? I guess this is one of those questions which is that depends. It depends on what type of cloud infrastructure you might start using. It depends what type of application it is, and also sort of the network availabilities you have, and also what regions you're acting in. But I guess the first thing is sort of the simplest thing is actually to get your websites out there. primarily because the size of them and the complexity of them is generally smaller than databases. Do you have a view on it, Sean?
No, I would tend to agree with you on that. It's usually get the simplest things out there first, the things that are the least complicated. That way you can spend more time on the complicated portions later.
Yeah. Excellent. Well, that seems to be all of the questions for today. So thank you for attending. We've really enjoyed today, and our follow-up email will contain any links to any useful information we think you'd like, including the recording of the webinar and also a link to the slides. If you do need any further information or you've got any more questions, then do get in touch either on our community Slack or at in our mailbox, which is advice@octopus.com. Please check on the website events page to check up with any future webinars. You can find it at octopus.com/events. The next webinar we have is a collaboration between Octopus and Redgate, and that's with Ryan on July the 15th. And then after that, we've got an Octo 101 getting started deploying to AWS, and that's on July the 22nd with Mark and Adam. Thanks again, thanks Sean, and happy deploying.